Derivatives of trig functions. By the end of objectives, by the end of this lesson, you should be able to state the derivatives of the 6 trig. So okay, let me go back. We're in IB, so it's only 3. If you ever take AP Calc or just calculus, it'll be 6, but IB only cares about the initial 3. So you should be able to state the derivatives of the 3 trig functions and work with them. So here are the 3 trig functions, again, all from your book. Derivative of sine is cosine. Derivative of cosine is negative sine. Derivative of tan is 1 over cosine squared. It's actually, I mean, it's also known as secant squared, but again, IB only deals with the main 3, not the inverse, not the other, not the reciprocal trig functions. So that's the only ones you gotta know. Sine is cosine. Again, this is all on your formula sheet too, so you gotta use them. You don't have to memorize them, but you pretty much will, because you're gonna use them so often. But derivative of sine is cosine. Derivative of cosine is a negative sine. That's important. Don't forget the cosine is a negative. And derivative of tan is 1 over cosine squared. But again, specifically these two you want to get used to. We're gonna use those a lot. Tan's a little less though. You can always refer to it in your formula sheet. Okay, now first things first. Couple rules when you're doing sine stuff. First, right, always stay in radian mode in your calculator. If you're gonna simplify something in your calculator, make sure you're in radian mode. When you graph, you want to be in radian mode, right? When you change the degrees, when you see a little degree sign. But for what we're doing, radian mode. Second, I kind of brought this up in an earlier video. If you see sine squared x or anything to that effect, it's the whole thing squared, right? So if I give you like cosine to the 4th x, that is parentheses cosine x to the 4th power, right? That's the way that works. So not saying that we'll deal with this in this class as much, but arc sine is not sine to, arc sine is the inverse sine, sine to negative 1. That is not 1 over sine, right? That's not a flip power. That's an inverse thing. Sine 2x, don't forget that's in your formula sheet. Sine 2x is 2 sine cosine. So that might come up some ways, either way, front or back. What you cannot do is pull out the 2. Why do you guys do this? Right? Sine 2x is locked in. You can't pull out that 2. That doesn't work that way. Same idea. If I give you sine 3x over 3, those 3's do not cancel. This is locked in. It's in a lockbox, right? That's stuck. So those don't cancel. You can't pull it out. It doesn't work that way. Right? So sine 2x is that. So you either do a chain rule or you rewrite it like this. Chain rule probably is the best preferable. So just keep that in mind. It's so important I wrote it twice. So just keep that in mind. So there's a couple of things. Now let's do some problems. Just with respect to x. So like everything else now, right? Everything's a chain rule now. For almost for the most part, unless it's super easy. Like this. Super easy. Alright, sine 2x, chain rule. Right, notice how there's something on the inside. Remember the chain rule is take the derivative of the outside. Leave the inside alone. Leave in alone. And times by derivative of the inside. Right? Probably best summed up by this. If you want the derivative, it's going to be f prime, derivative of the outside, leave the inside alone, times by derivative of the inside. So in this case, my outside sine, the derivative of the outside is cosine. We just learned that a second ago. We're going to leave the inside alone, and then times by derivative of the inside. So 2. So 2 cosine 2x. If you want to make it prettier. Moving on to the next one. Cosine 3x minus sine x. Right? So again, we have another chain rule right there. So that's inside the cosine. So take the derivative of the outside. The derivative outside of cosine is negative sine. Cosine only has a negative derivative. Leave the inside alone, then times by derivative of the inside. Over here, derivative of sine. Hey, look, a basic one. Derivative of sine is cosine. Again, if you want, you can make it a little prettier, but that's the general idea. Moving on to the next one. This is the one that everybody gets wrong. Look what's going on. X sine x. It's a product rule, right? You're multiplying this function by this function, right? Very different than if I give you 3 sine x, because that's a constant, right? We don't have to worry about the product rule there. It's 3 times whatever the derivative of sine is, which would be cosine. Over here, product rule. 2 functions, product rule. So, right, the product rule is the derivative of the first times the second plus the derivative of the second times the first. It's in your formula sheet. This is easy enough. Derivative of x is 1 times sine plus the derivative of sine, which is cosine, times the other one left alone, times x. So this is the same thing as saying sine of x plus x cosine x. Right? Right, so it's more like a review of everything, right? We got to know our product rule. You can't forget anything. Product rule, quotient rule, power rule, chain rule, definitely we're going to use all the time. Now let's look at this one. I want to point this one out because these two are different. Yeah, those straight lines. So this is x times sine x, right? X times sine x. right? Product rule. Look at this one. This is not natural log times sine x. This is natural log of sine x, right? Not a product rule. I mean, I know of means times sometimes, but not a product rule. This is a composition of function. It's sine of this natural log of sine x, right? So this is a chain rule. There's a function inside another function. They're not being multiplied. Multiply would be this, right? That's being multiplied. By the way, you never see sine by itself. I see people do this sometimes. Sine of 2x will be like, oh, this is a product rule, u and v. No. Sine, you never just see this. That's nonsense. It has to be sine of x. That's why this is not a product rule. This is a chain rule. So anyway, chain rule right here also. Now remember the chain rule for natural log? It's 1 over the inside times the derivative of the inside. So derivative of sine is cosine. So you get cosine x over sine x. My awesome trig students would know that that's cotan, but IB doesn't really do cotans, so you just leave it like that, cosine over sine. And also remember, IB you don't have to simplify unless they specifically ask you to. So look at some of these. Cosine cubed 4x. Now remember, the first thing with this is the thing I told you about earlier. You have to rewrite that. It's the same thing as saying cosine 4x all to the third power, right? That's the way you want to rewrite it. It helps you solve a problem so much easier, right? Anytime you see that, it's the whole thing to that power. Now what we have here is we call a nested chain rule. So there's like different levels. Cosine 4x is inside 3x, but 4x is inside cosine. So there's actually a couple levels of chain rule here. So take the derivative of the outside. We were outside in, so bring that 3 down, subtract 1 off. There we go. So bring the 3 down, subtract 1 off, so it's 3. Leave the inside alone. Right, like that. Don't forget, a lot of people forget the second part, times the derivative of the inside. Right, I haven't done that part yet. Very important part of the chain rule. Right, chain rule is this times u prime. A lot of people forget the u prime. So let's take the derivative of this. Now, derivative of the inside is itself a chain rule, right? Derivative of cosine is negative sine. Leave the inside alone, right? And then times by derivative of the inside, 4. So you get that. Again, you can do it like that unless they specifically ask you to, but keep in mind, I put a little times there, or parenthesis sign will work also. So it does not look like you're subtracting sign. So this might be one where it's helpful to simplify it. So you get negative 12 sine of 4x times cosine of 4x squared. Right? So just so you know you're not subtracting sine x, so it looks like you're multiplying. So with that in mind, look at the next one. 4 tan squared of 3x, right? It's going to be the same idea. First thing you do is rewrite it 4 tan 3x whole thing squared. Now again, this 4 is a constant, so that's not a product rule. Constant numbers just stay there. You just do your thing and then multiply by 4 afterwards. They're easy, right? But this is another double chain rule thing, right? Where the outside is 2. So take the derivative of the outside, bring it down, subtract 1 off. So I get 8. So the first power, leave the inside alone, so tan 3x. Then don't forget, you have to multiply by the derivative of the inside. Derivative of tan, we haven't used that very often. It's in your formula sheet. It's 1 over cosine squared. So 1 over cosine, leave the inside alone, squared, times by the derivative of the inside, which in this case would just be 3. Right, so that's my derivative. My derivative is like, if you want to make simplify, if you want to, you can simplify it. 24 times tan 3x over cosine squared 3x. Again, don't have to do that unless they specifically ask you, but that's what it looks like. Right, so this or this. Couple more. So this one right here, if sine of e to the negative x, if f of x equals sine to the e to the negatives, then f prime of x equals what? So on this one, again, notice not a product rule. Chain rule, right? It's not sine times e to the x, it's sine of e to the x, right? You don't see an x there, right? You never have sine alone that can happen. So this is chain rule. So chain rule is take the derivative of the outside, which in this case will be cosine, do the inside alone, and times by derivative of the inside. Now this is its own chain rule. We talked about it, right? E is pretty much always its own chain rule. But the shortcut is just copy it, and times by derivative of the inside. In this case, will be -1. So that's the answer, right? It's negative e to negative x cosine e to negative x, right? So this stuff is getting a little more complicated, but just kind of bring all your powers together, all your derivative powers together, rules. So last one. Let's put everything we put to the test and make sure we know our trig functions. F of x equals sine cubed x at the point where x equals 2 pi over 3. So I think I cut off the problem. It wants you to find the derivative at the point where x equals 2/3. So sorry about that. So let's take the derivative of this. Remember, you want to rewrite that. Sine x whole thing cubed. So the derivative, bring the 3 outside down, subtract 1 off. 3. Need the inside alone. Times by derivative of the inside. Derivative of sine is cosine. Again, notice it's sine x, cosine x, right? You never have a sine or cosine by itself. So that's my derivative. Now they want to add 2 pi over 3. So 3 sine 2 pi over 3 squared times cosine of 2 pi over 3. So hopefully we know our trig, right? A couple ways to do it. You could do the box method, you could do the memorization method, you could do the triangle method. I'm a triangle fan, so here's 0, here's pi. 2 pi over 3 we're over here. Remember, you have to do this no matter which way you do, you have to know what quadrant you're in. And we're in quadrant 3 because this is 3 over quadrant 2. This is 3 over 3, and you're 1 less, so 2 pi over 3. Right now, if you're doing the box, go look at 3, go look at cosine and sine, you're done. Don't forget all students take calculus if you're doing the box people. But over here on the good side, we're going to go 30 is 60 degrees. Over here is rad 3. -1 because that went left, and then 2. Sine is SOHCAHTOA. So opposite of hypotenuse is rad 3 over 2. Don't forget this is all going to be squared. Cosine is at SOHCAHTOA. A over h, so -1 over 2. Do a little algebra. Remember the square goes to both of them. So I get 3 times, rad 3 squared is just 3. 2 squared is 4. Times -1/2. Remember the way you multiply fractions is multiply the tops together, multiply the denominators together. So I get that. Nothing to it. And that's the derivative of trig functions.